Greetings, Mr. Sutton here with the BC Calculus 7-2 Part 2 Homework Solutions on Maclaurin series. For this no calculator free response problem, we have a function f with derivatives of all orders about 0, and p sub n is the nth degree Taylor polynomial about 0. So, first part, it's known that f of 0 is negative 4, and the value of the first polynomial, first order polynomial at 1/2 is going to be equal to negative 3. We just want to show that f prime of 0 is 2. So to do this, let's set up a general formula for the first order polynomial. That's going to be f of 0 plus f prime of 0 times x, just using kind of a very truncated version of our Taylor nth term polynomial here. All right, so we actually know a few of these values. We know, for example, that f of 0 is negative 4. And we also know that we're trying to plug in 1/2 to this first order polynomial. So that means we have an x value of 1/2 getting multiplied by my f prime of 0. And finally, we know that when we do plug in 1/2, we should get back a value of negative 3. So that's what this p sub 1 of x out here is going to be. At this point, we just have to solve for f prime of 0 and hope it actually comes out to 2. So we can start by adding 4 to both sides. That's going to be 1 equals f prime of 0 times 1/2. And then multiply both sides by 2 or divide by 1/2, either way, we get f prime of 0 equals 2, which is exactly what we were trying to show. For this next part, it's known that f double prime of 0 and f triple prime of 0 have these values here. Based off of that, we just want the third order polynomial for this function. So we've got our first two that we already saw before. That was negative 4, and we saw that the first derivative was 2, so negative 4 plus 2x. Those are the first two terms that they kind of gave us for free on this. But now we need to get the next one. The next term is going to be f double prime of 0 over 2 factorial times x squared. So in this case, that's going to be negative 2/3 over 2 factorial, which is just times 1 over 2 times x squared. For this next one, we're going to have f triple prime over 3 factorial. So that's going to be 1/3 times x cubed over 3 factorial for this one. And we're actually done. We don't have to simplify this any further since the x's don't have any weird thing going on with the exponents and don't need to be simplified. However, if you did want to simplify this, because you're going to need to do it for the last part of this free response anyway, this is going to come out to, let's see here, these 2's actually cancel because this is just 2 down here. So this is negative 1/3 x squared, and over here 3 times 6 is 1 over 6 or 1 over 18 down there. So we have negative 4 plus 2x minus x squared over 3 plus x cubed over 18 when the dust settles on this one. For this last part, we have some function h whose first derivative h prime is given by f of 2x, and we also know that h of 0 is 7. Based off of that, we want the third degree Taylor polynomial for h about x equals 0. Well, if you're starting with an h prime that you can find and h of 0, you're probably going to need to use the fundamental theorem somewhere down the line. So for example, maybe do h of 0 plus the integral from, say, 0 to x of h prime of x. Before we can do any of that, though, we need to figure out what h prime of x looks like. So for that, I'm going to need the f function, and I don't know the exact f function, but I've approximated it out to 3 degrees. So let me just rewrite what I got in part B here. This was my third order Taylor polynomial for f. So we're going to just plug 2x into this function, and that'll give us some idea of what h prime looks like. Now for h prime, I only need to go out to this second degree here, because they want the third degree Taylor polynomial. And we're going to end up getting that by integrating. So I'm only going to go up 1 degree, but that means I actually don't need this third degree at all, because this would turn into the 4th degree if I were to integrate some expression with this in there. So I'm just going to plug then 2x into the first 3 terms. So that gives me negative 4 plus, this is 2 times 2x, minus, this is going to be 2x, the whole thing squared over 3. And then I'm going to simplify this because I'm going to need to integrate it down the line here. So this is negative 4 plus 4x, and this is going to be minus, let's see, this is 4/3 x squared. All right, so now to get h itself, because this was just an approximation of h prime, notice I wrote approximately equals here, I'm going to have h of 0, which we said was 7, plus the integral from 0 to x of h prime of t dt. I have to put t in here because I'm already using x as my upper limit of integration. And I'm going to write that this is all approximately equal to the following, because I don't actually know h prime, I just have an approximation of h prime up here. So I've got 7 plus, and now I have to take the antiderivative of all this stuff. Now, before I use my evaluation box and plug x into all this stuff and subtract all this, the antiderivative stuff with 0 plugged in, notice that when I take my antiderivatives, my first term is going to have an x in it, as will the rest of them. So when I plug in 0 down the line, that's going to zero everything out, which means I don't actually need the evaluation box. I just need the antiderivative of all this with x plugged into it, because 0 isn't going to really make any difference when I plug it in. All right, so going from left to right, antiderivative of negative 4 with respect to, that's going to be x at this point. This is going to be negative 4x. And for this next one, this will be plus 2x squared. And then for this last one, this bumps up to a 3. Dividing by that, we've got negative 4/9 x cubed. And this is our approximation, our third degree Taylor polynomial for h about x equals 0. On this problem, we're given this polynomial. They're telling us this is the 5th degree Taylor polynomial for some function about 0. Based off of this, we want the value of f triple prime of 0. So to do this, I'm going to use my coefficient formula, which is, for this, it's going to be f triple prime of 0 over 3 factorial, represents the coefficient in the Taylor polynomial. So I'm going to write f triple prime of 0 over 3 factorial equals the actual coefficient here, which is negative 5. And at this point, all I have to do is solve for f triple prime of 0. That's what they actually wanted. So I'm just going to multiply both sides by 3 factorial, which is really just 6 times both sides, giving us negative 30 for that third derivative. So that's choice A. For number 6, they want to know the coefficient of x squared in the Taylor series for this function about x equals 0. So they're basically asking for the coefficient of x squared in a Maclaurin series. We know that in general, that's going to be the second derivative of 0 over 2 factorial. And that just gets multiplied by x squared when you're actually constructing a Maclaurin series. So we need to find the second derivative of this at 0 and then divide it by 2 factorial. All right, well, let's find our first derivative. So I'll just think of this function as being 1 plus x to the negative 2. So then my first derivative is negative 2, 1 plus x to the negative 3. Taking another derivative, that's going to be 6, 1 plus x to the negative 4. And I'm going to evaluate that at 0 to figure out f double prime of 0, which is what I actually need out of all this. So plugging 0 in here, 1 plus 0 is 1, 1 to any power is 1, so this is just then 6, which means our coefficient is going to be 6 over 2 factorial. Since 2 factorial is really just 2, this is 6 over 2, which equals 3. Choice D. For this problem, we want to know the coefficient of x squared in the Taylor series for sine squared of x about x equals 0. So in general, my coefficient for the second power is going to be the second derivative of 0 over second factorial. So all I have to do is figure out the second derivative of this function at 0, plug it in here, and I'll be done. All right, well, let's start with the first derivative of sine squared. That's going to be 2 sine first power of x times the derivative of the inner function. Derivative of sine is cosine. So then this is 2 sine of x cosine of x using our chain rule. And I could use a product rule at this point to take the second derivative, and it wouldn't cost me too much time. But you might recognize from your pre-cal days that this is actually one of those double angle identities. This is really the same as sine of 2x, which is a slightly easier derivative to take. I don't need a product rule at this point. Derivative of sine of 2x is just going to be cosine of 2x times a tail of 2. So then f double prime of 0 is just this with 0 plugged in. Well, this is really just cosine of 0, which is 1, times a 2 out here gives us a grand total of 2. And then 2 plugged in here for f double prime of 0, that's going to be 2 over 2 factorial. This is really just 2 over 2, which gives us our x squared coefficient of 1. So that's choice D. On this problem, we're given this function f of x is 1 over 2 plus x. We want the coefficient of x cubed in a Taylor series about x equals 0, so in the Maclaurin series. All right, well, our general formula for the coefficient of x cubed in a Taylor series is just going to be the third derivative of 0 over 3 factorial. So we just need to figure out what f triple prime is, plug in 0, and then divide that by 3 factorial. Well, let's just rewrite the f function to make this a little easier to take repeated derivatives. I'm going to write this as 2 plus x quantity to the negative 1 power. And now I can just use my power rule over and over again. So the first derivative is going to be negative all of this to the negative 2nd power. The second derivative, I'm going to have positive 2 times all this to the negative 3rd power. And we need to go one more time. Third derivative, I've got negative 6 all of this to the negative 4th power. Plugging in 0 for all of this now to get my third derivative at 0, I'm going to have, let's see, this is really 2 to the negative 4th, which is 1 over 16, because it's really 1 over 2 to the 4th. So this is negative 6 over 16, which reduces to negative 3/8, which is an answer choice. But wait, there's more. We still need to divide f triple prime of 0 by 3 factorial. That's why I wrote this out in the beginning, so I wouldn't forget to do it. So if I'm dividing this stuff by 3 factorial, I'm really dividing it by 6. And dividing by 6 is really the same as multiplying by 1 over 6. Same change flip. So the 6's here are going to cancel, leaving me with just negative 1 over 16, which is also an answer choice, choice C. For this fun problem, we have a function f with a Maclaurin series given by this stuff here. And we're told this Maclaurin series converges to f of x for all real numbers x. So basically, when you need to do f of anything, you're basically just plugging it into this expression here, and hopefully that works out for you. So now the g function is defined as g of x equals e to the f of x. Based off this, we want the coefficient of x squared in the Maclaurin series for g. So in general, the x squared coefficient in the g function is going to be g double prime of 0, 0 because it's a Maclaurin series, g double prime of 0 over 2 factorial. So if we only knew what g double prime of 0 was, we could figure this out. Well, we don't know what g double prime of x in general is. We don't even know g prime of x. So let's start by finding that. For g prime of x, we're going to need to use the chain rule here. This is going to be e to the f of x times the derivative of this exponential part, so times f prime of x. So that wasn't so bad. That's g prime of x. For g double prime of x, however, we're going to need to use the product rule. So that's going to be u prime v plus uv prime. Let me set up my box and ribbon to help me with this. So up here, I've got my first factor, e to the f of x. And then I've got f prime of x, which if I want to, I could actually define that a little bit. So that's just the derivative of this Maclaurin series. So that's going to be 3 plus 2x plus, let's see here, this will be just 3 and 1/3 cancel, so x squared, and so on and so forth, because they didn't give me more, so I'm not going to give them more. All right, so now we need the derivatives down here. This is u prime and v prime. So the derivative of e to the f of x, well, actually, we just took that. That was the derivative of g of x in general. So that's just e to the f of x times f prime of x again. And derivative of f prime is, well, f double prime. But we can be a little more specific. If this stuff here represents f prime, then f double prime is going to be, using the power rule here, 2 plus 2x, and so on and so forth. So we need to figure out g double prime of 0. So if x equals 0, let's see what happens if I plug that into each of these parts of my product rule that I'm doing over here. So in the upper left, we have e to the f of 0. Well, f of 0 is basically what I get when I plug 0 into this original Maclaurin series. So that zeroes out everything except this constant 2 in the beginning. But now hold on a sec, I have e to the f of 0. So this is really going to be e to the second power. And now f prime of 0, that's going to be what I get when I plug 0 into this f prime term here. That zeroes out everything except this 3 in the beginning. Down here we have e to the f of x times f prime of x, but we have 0 plugged into both of those terms. Well, this right here was e to the f of 0. This was f prime of 0. So if I multiply these together, I just get 3e squared. So that was actually easier than I thought it would be. And now we have f double prime of 0. If I plug 0 in for all the x's in this Maclaurin series, this is going to end up being just 2. So now multiplying this out with the ribbon to get g double prime of 0, that's going to be 9e squared going this way, plus 2e squared, which I can simplify to 11e squared. But hold on a sec before you pick 11e squared. It's actually not even an answer choice. Remember, we wanted the coefficient of x squared, which was g double prime of 0 over 2 factorial. So we actually have to divide this 11e squared by 2 factorial, which is really just going to be 11 halves e squared. And that matches answer choice D. For number 10, p is some polynomial that's the 4th degree Taylor polynomial for some function about 0. We want the value of the 4th derivative of 0 for that function that this polynomial represents. Now, this is actually a pretty easy question if you understand how this polynomial was built. The 4th degree term is really just going to be the 4th derivative of 0 over 4 factorial times x to the 4th. So our coefficient of x to the 4th is just the derivative we're looking for divided by 4 factorial. That's how these Maclaurin series are built. Well, this stuff here equals, in fact, if you look at the polynomial, the coefficient is actually 6. So that means that whatever all this stuff was, it has to come out to 6 in order to simplify to this expression here. Okay, well, to get 4th derivative by itself, we just have to multiply both sides by 4 factorial. So we have 6 times 24 essentially. That's going to be, let's see, 120 plus another 24, that's 144. So our 4th derivative then is 144, choice E. For number 11, f is a function with the 2nd derivative f double prime equals this radical expression. The coefficient of x cubed in the Taylor series for f about x equals 0 is, all right, so in order to get the coefficient of x cubed the way these Taylor series are built, we need the 3rd derivative of f at 0 over 3 factorial. So we need to find that 3rd derivative then and then divide it by 3 factorial. The good news is they already gave us the 2nd derivative, so we just need one more derivative. This is really 1 plus 3x all to the 1/2 power. So I can just do 1/2 times all this stuff to the negative 1/2 power times a tail of 3. And that is my 3rd derivative. But now I have to actually plug 0 in, so let's make this into a format that's easier to work with. So I can make this 3 over 2 times the square root of 1 plus 3 times 0. So we've got really just the square root of 1, which is 1. So that's just a 2 down there when all is said and done. So then 3 over 2 is going to be our 3rd derivative at 0. Now that is one of the answer choices, but before you jump the gun and pick choice E, remember we had to actually divide this by 3 factorial to get that coefficient of x cubed. So 3 halves over 3 factorial, that's really 3 over 2 over 6, or 3 over 12, which we can reduce to 1/4. Choice C.